Mhm.
Yes, I'll share tomorrow's movement. Okay. So in the yesterday's class, we had seen majorly the random samplings. The pen is not- We had seen in yesterday's class random sampling, and in that random sampling, this was the best way, good sampling method. In that we had seen what it was, simple random sampling. Simple random sampling. In that simple random sampling, there we had explored two main methods of sampling. That is sampling with replacement, and replacement, and sampling without replacement, and sampling, sampling without replacement,
Mhm.
without replacement. Yes. Okay, that was the thing. Then we had started with the second thing. That was, I think, we had seen the using D table. I think we will see one more time today how to use the D table. Okay, I'll give you one more example. And the second was strata or stratified sampling. Stratified sampling. Stratified random sampling. It is also a random sampling term. Stratified random sampling. Okay. So first of all, what we'll do, we'll just see first example of our D table. Okay. So using of D table, using of D table. Okay. Using of D table. So how it is, I'll take our D table from the textbook. Okay, okay. So how it is, see, for suppose that I'll write down some names. Likewise, my name, pen isn't working. Shoaib, for example, Samir, okay, Shazia, Husna, Rahim. Okay, all Indian names I'm writing, all John with. Andrew, Bill Gates, Bell, okay, Cook, okay. Then you can join one more name. Okay. Now, for suppose I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 20. These are 1, 2, 3, 4, 1, 2, 3, 4, 16. 16 names, and I have to choose from the 16 the 8 names. Randomly, I have to choose 8 names. Okay. So first of all, how to do random sampling is the best example. So he has given us some steps here. Okay. So what are those steps? That label. So the things that we have to choose, it can be either numerical or categorical. Numerical
Yeah.
or categorical. So categorical. So first of all, what we have to do, we have to give them numbered labels. Numbered labels means what? We have to assign a number to each of them. So for suppose Shoaib has the number 101, okay, uh,
Mm-hmm.
02, okay, then 03, then 04, 05, 06, 07, 08, 09, 10, 11, 12, 13, 14, 15, and 16. Now what I have to do, I have given each member, each individual in the population a label. Yes or no, Zaid?
Yeah.
Yeah. So now what I have to do, according to this label, I have to select any one of the row, any one of the row from the D table. We have this D table. The D table is very big. In the general sense, the whole D table. So we can choose any one row. Now what we have to do, for suppose I have chosen this 102 row, 102 row, or for suppose we'll go with 101. Okay. So now we have to, what we have to do, select any one row here. After label, then we have to randomize. Randomize means select any one row, and how much is the length of our label? It's 2. So I'll go on selecting these two numbers. So 19. Is 19 in our range? We have a range of label from 1 to 16. Yes or no? Right?
Mm-hmm.
Yeah. So is 19 in our range? No. So we'll cut it. Then we have 22. We don't have. Then we have 39. We'll cut it. Then we have 50. We'll cut it. Then we have 34. Why I am cutting? Because these numbers is not in our range. Then we have 05. We have 05. So the first member that will be in the committee, we have to select make a committee of 8 members. So the first member that will be in our committee will be the the member with label 5. So committee, I'll write down the committee here. About it, committee. Alhamdulillah. Committee. Okay, the first was 05, and it's the name Samir. Okay, okay. So it's Samir. So the next number is 75. We doesn't have 62 knots, 87 knot. Then it's 13. Yes or no? 13 is there. Then who
Mm-hmm.
is on 13? That's Usman. So I'll take 13. I have to make only 8 members committee. The second one is Usman. Okay. So now 13 is done. Okay. 96 is not there, 40 is not there, 91 is not there, 25 is not there, 31 is not there, 42 not, 54 it's not there, 48 not, 28, 53 is also not there, 73, 67, 64, 71, 50, 99, 40, 00. 00 is there, and then 19 is there. Okay, 19. Then there is 27. We don't have 19. We don't have 27. 75, 44, 26, 48, 82, 42, 53, 62, 90, 45, 46, 77, 17. 17. Okay, 09 is there. Okay, 09. So who is on 09? 09 we have okay, okay, 09. We have Shazia. Okay, okay, Shazia. Okay, then 09. Just a minute. Okay, 09 is Shazia. Then we'll go more further. 09. Then 77 is not there. 55 is not there. 80 is not there. Again, 00 is not there. 95 is not there. 32, 86, 32, 94, 85, 82, 22 is also not there. 69 is not there. 00 is not there. 56 is not there. See, our D table has finished. How many committee we have to choose? For suppose we have to choose. Now what I have to do? I have to bring that D table from the internet. So it will require time. So what I'll do is committee of three has to be chosen. So what are the three members that have chosen Zaid? Samir, Husna and Shazia. Yes or no?
Yeah. Yes,
Yes.
exactly.
This that we have done, it is known as simple random sampling. Okay, and if for suppose I have to go through this table once more. For suppose the further line was this, and 13 is repeated. 13 is repeated, and we are doing simple random sampling. Yes or no? Simple random
Mm-hmm.
sampling. So in simple random sampling, we use sampling without sampling without replacement, or you can say without replacement. So when 13 comes in the next, what we'll do, we'll just cut it, we'll skip it, we'll don't repeat that 13 number. Is it clear? So that's the thing. So this is known as simple random sampling. Using what we have used, it is very convenient to use. It is very convenient to use D table. It is very convenient. Why it is convenient to use D table? Because human selecting, randomizing by humans, randomizing. If for suppose I'll tell me random numbers between 1 to 100, so there can be some biasness in human brain. Randomizing can be biased by humans. So therefore we prefer that giving labels. What are the three steps for using D table? I'll write it down. Using D table, it is first of all, individuals label the individuals by the least possible numbers. Okay, then what it is, then it is randomly go through the D table, randomly go through, no, not randomly. Okay, now then second is, I'll write something else. Using D table. Now select any one row of the now select any one row from the D table. Select any one row from the D table and go through it with the need of searching the labels, searching the labels that we have given to individuals till our expected sample size. For suppose that I have to choose three, so that the expected sample size is met, and the numbers outside our labels outside our labels is to be skipped. How we have done is to be is to be skipped. Okay, that's the thing. Then third point, when n members are selected, n members or you can say labels are selected, just form the sample of that member. Just form the sample of that individuals. That's the thing. Is it clear, Zaid, the use of D table? Is it very clear? Yesterday I didn't given you an example, but today we have seen an example also. Is it clear?
Mm-hmm.
Okay. So that was the use of D table, and it is very interesting to use D table because I've told you biasness is there. Biasness is always there in humans, but in a table that's designed to for a task of D table is designed for the task of selecting the random numbers only. So there is very least chance, means a possibility of 1% that the D table will be biased. Okay, so that's the D table. So now the year it was the use of D table. Each year, the State Department of Education randomly selects randomly selects 3 schools from each district and conducts a detailed audit of their attendance. Describe how to use a table of random digits. So I'll take this. So what I have to just do, we cannot collect the attendance of each and every school and then go on selecting it. So what we have to do generally, for suppose again we'll give them the labels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Okay, so we know when we will look into this D table. I'll take this upside. So, okay, so it's 11 here. Then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we'll go on to the D table. Likewise, I'll bring one more time the D table here. Is it given here? No, D table is not given here. So where is the D table? Okay, it's here. The D table is quite big. If you want to see, we'll go there. Wait. Just a minute. I'll show you how the D tables look there only. How big it is. Yeah, see how it is. This is also. This is a Z table. Oh, sorry, the D table. This is a Z table. Table of random numbers. See. Okay. So see, now we'll go through it. Okay. So we have 19. Our label range is from 1 to 19. 1 to 19. So we'll search for numbers from 1 to 19. What I'll do, I'll make the pointer of my pen more smaller. More smaller. Okay. So 36 is not in our range. 51, 83, 67, 77, 89. Then it's 11. 11. 11. So what's 11? 11 year it is. Okay. So first of all, what was the question? I'll see just for my reference. Okay. So describe how to use a table of random digits to select a SRS of three schools. So we have to select only three schools. Is it correct? So as we will be we complete selection of three groups. We'll stop to the table. So 60 is not in our range. Okay. So 60 is not our range. 55 is not there. 42 is not there. 29 is not there. 70 is not there. 58, 37, 75, 21. I think it's there. Yes, our range is from 1 to 19 only. Okay. 1 to 19 is there. No? So 21 is also not there. 21 is not there. 56 is not there. 48, 16 is there. 16. Okay, 16. 16. Where is 16? This one. 16 will be there. Okay. Then 39 is not there. I'll mark down 16 here. Okay. This also I have to mark. 16 is here. 92, 79, 73, 62, 41, 38, 56, 52, 62, 81, 75, 78, 81. 46, then it's 13. 13, what it is, where is 13? 13 is here. So, Zaid, see, I'll not go further in this table. Why? Because my sample size, as I have met my sample size was only three schools. So the data that I'll collect from the schools are it's Keeling Elementary
Mm-hmm.
School, okay. Then it's Mesa Worthy Elementary School, okay. Then it's Prince Elementary School. This is the thing. Is it clear, Zaid?
Mm-hmm.
Okay, so we have completed one example of using the D table because it is very important. We will require in all random samples. So the next that we had started yesterday was our strata or stratified random sampling. I have given you all the introduction about stratified and we have seen one example also. Yes or no? Stratified. Just I'll revise it. Stratified random sampling. So what is it is that distributing the population based on some of the characteristics based on some characteristics that the population has, it must have, then only we can distribute na? Based on the some characteristics and forming groups based on the characteristics based on the characteristics and then randomly selecting it, and then because it is stratified random sampling and then randomly selecting it. How do we select randomly? We'll never go random by our brain, but by detail. Randomly selecting it is called as stratified random sampling. Is known as stratified random sampling. Did you got that? So that's the thing. I have given you an example that we have. For suppose I am collecting blood groups. No, I am what you will say. Huh, okay, chalo. I am collecting blood groups of individuals. There are various individuals. Okay. So what I can do based on very individuals, there is a very large size. So what I'll do, I'll make groups that how many individuals are A plus B plus, AB plus. Okay, I'll make the groups of this O plus, then A minus, A negative, B negative, AB negative. So these are all the groups. I have made these groups from the population. I have made these groups, groups based on the characteristics of blood group, based on the characteristics of blood blood group. Okay, right? That's all the thing. So we'll see one example. Okay, come on, read this. I'll just make a phone call. Just read this example, right?
Yeah. All right.
Okay, so I'm back. So a British farmer grows sunflowers for making sunflower oil. A field is arranged in a grid pattern with 10 rows and 10 columns. Okay. Okay. What I'll do
Mhm.
is very simple to take these all things on our board, then discuss it. So, okay. Wow, there is a farm, and he has 10 rows. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 columns and 10 rows. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. Okay. So, shown in the figure, irrigation ditches run along the top and bottom of the field. Run along the top and bottom of the field. The farmer would like to estimate the number of healthy plants in the field so she can project how much money she will make from selling them. It would take too much time. Yes, it would take. For suppose this is one specific row, then we have to count each and every sunflower. Okay, for it they have a hundred many of the sunflowers. Okay, so the farmer would like to estimate the number of healthy plants. So in this field, this complete field, we have to give an estimation that how many healthy plants are there we can get from this. So what we need to do, we did not need to select each and every sunflower and check its health, whether it is healthy or not. Just what we'll do, select some of the sunflowers by random sampling, and then we can tell whether it is based on our sample. It is a big population. We'll collect a sample of around lesser than the population, and then we'll check whether how much of them are healthy. Then we'll comment about the population. Comment on population based on our sample. How we'll collect the sample? By doing a random sample. So the farmer would like to estimate the number of healthy plants in the field, so can project how much money she'll make from selling them. It would take too much time to count the plants in all 100 squares. There are 100 squares, yes or no? There are 100 rows, 10 rows and 10 columns. So there are around 100 squares. So she accepts and estimates based on a sample of 10 squares. So what we have to select? See, for suppose I have two rows and two columns. Two rows and two columns. Okay. This is my, for suppose this. So how many squares I have? One, two, three, four, five, six, seven, eight, nine. Yes or no? Two rows I have, not two rows. Okay, and two columns. Yes, two rows and two columns. Suppose this is my column. So this will be our two rows and two columns. So this is the thing. So for how many squares I'll have? Four. Four squares. Yes or no? Now there are 100 rows and 100 columns. So there will be 100 squares. So from that 100 squares, we will take the C. This is the population. Population size is 100 squares. 100 squares. Okay. Now what we have to do for a sample, be a subset of the population, we have to select 10 squares. Okay. Okay. So what we'll do, number the squares from starting to end, in the population. For example, this is my population. So one, two, three, four. I'll just drawing a sample, not the perfect 101. But for suppose this is the 100 square, so I'll name it as 01, 02, 03 labels. We have seen how to do labels, right? Yes or no? The previous example.
Mm-hmm.
So we'll do like that. So use D table or technology to take a simple random sample of 10 grid squares. Record the location. Example B6 of squares you select. For suppose we have given these are the labels. These are the labels, okay, that we are given. But
Mm-hmm.
what does the square represent? For suppose we are giving them A, B, C, D, E, F, and here as 1, 2, 3, 4. So what will be this? For suppose 0, 1 is there. So what is the position of it? A1. For suppose this is there. So what is the position of it? For suppose I have given the label 7, 14, 15, 16, 17. Here it would be 18. Okay. So but it has selected, it has come in the D table. So what will be the position of this? It will be D3. Are you getting Zaid? How we have
Yeah,
labeled it?
yeah, got it.
So that's the thing. This will be, I have explained you how to do it. Okay. So this time select a stratified random sample. In the second question, he's telling that this time select a stratified random sample using the row as strata. Use table D or technology to randomly select one square from each horizontal row. Record the location of each square. For example, row 1, G, row 2, B, and so on. Now what we have to do, uh, he has given is that easy? Has he given the figure of it? Oh, yeah, yeah, it's the figure. Okay. So we have to do stratified random sampling. So generally what we need to do, this time select a stratified random sampling using the row as strata. So we need to use this row as a strata. Okay, as a group. So use the D table or technology to randomly select one square from each horizontal row. So now what I'll do, I'll put the numbers according to the row. For suppose this row is selected as 1, this row as 2, this row as 3. I'll give this 0, 1, 0, 2, 0, 2, 0, 3, 0, 4. Then in that row, I will select any one as it. Okay. So each horizontal row, record the location of each square. For example, row 1, for row 1, it will be G. Okay. Then row 2, B, and so on. Now take a stratified random sampling using the columns. Means what? For suppose I am on row 1. Okay. Now I look into the table, D table. So for suppose I got a number, likewise in the G column. So I'll select it as my sample. Now I look into 2. Okay. Now I got B. So I'll give at in the sample B. Now I'll look at 3. Then I'll got a sample in the D table, a number corresponding to this. So I'll give like that. Okay. Did you got that, Zaid?
Mm-hmm.
Yeah. Are you there?
Yeah, got it.
Yeah. So now take
Yeah,
a
got it.
stratified
I got
random
it.
sample using columns as strata. Now what I will do? We'll take columns as strata, columns wise. A, then what will be? It will be for suppose 5. Then B, I have looked into the D table, then it would be 7. So strata, use table D or technology to randomly select one square from each vertical column, record the location of each square. For example, column A, then it's 4. Column B, it's 1, and so on. We have to just generally what we can do, uh, we have to uh, record the sample based on the column in based on the column when we have selected strata as a column. Okay, that in this
Mm-hmm.
column this square is there, this square, this square is there, and when we are giving as row strata, then I have to give that this square is there in row, that is stratified. We have distributed means made a strata based on a column as well as a row. Now we'll see how it looks generally. Now first we'll read all the questions here. So your teacher will provide the actual number of healthy sunflowers in each grid square. Use the information to calculate your estimate of mean number of healthy sunflowers per square in the entire field for each of your samples in step 1. In step 1, we have done simple random sampling. In step 2, we have done stratified random sampling using row as a strata. And in step 3, column as a strata. Many comparative dot plots showing the mean number of healthy sunflowers obtained using the 3 different sampling methods for all the members of the class. Describe any similarities and any differences you see. So what we need to do, we need to perform all these tasks. So see, he has done it. How we have performed here. So mean number of healthy plants, mean number of healthy plants using that SRS, simple random sampling. Then it is mean number of healthy plants row as beta, and mean number of healthy plants using columns as etc. On other details stands out in the graph. There is much less variability in the estimates. You can see that there is no much variability in the estimation based on the 3 different random samplings. Okay, when you use the row as standard, the table provided by your teacher shows the actual number of healthy sunflowers in each grid square. Notice that the square within each row are relatively homogeneous because they contain a similar number of healthy plants, but that there are big differences between rows. When we can choose strata that have similar response, example number of healthy plants within the strata but different responses. Okay, so that's known as stratified random samples, give more precise estimates than sample random samples of the same size. Okay. So why didn't using the columns as strata reduce the variability of the estimates in a similar way? Because the number of healthy plants vary a lot within each column, and aren't very different from other columns. So both simple and random sampling and stratified random sampling are hard to use when population are large and spread out over a wide area. So what we have seen a drawback of these, when population is very large, when population is very large, so it is not efficient. So it is not efficient to use SRS and stratified strata random sampling. Strata random sampling. As we have seen that there is less variability in the 3 of them, but there are differences in their graph. So then there is cluster and cluster sampling. So this is a new method. Till now we have studied simple random sampling and stratified random sampling. Now this is a new sampling method that is known as cluster sampling. Write it down, third one. Cluster. What is meant by a cluster? Cluster is just a part of a cluster you can say, or it is also known as a subset. But subset is a part, it is also a part, but it is a defined part. And cluster is just a part of a population
Mm-hmm.
which we select randomly. Which we select generally we select randomly. Select generally by random method. By a random method. So this by sampling using cluster is known as cluster sampling. Cluster is a group of individuals in the population that are located near each other. Cluster sampling selects a sample by randomly choosing cluster and including each member of the selected cluster in the sample. What do we generally do? That for suppose it is generally explained by a Venn diagram. For suppose this is my population. This is my population. Okay. And there are various individuals in your population. In this ML and machine learning and this clustering is also there. So what I'll do, where there are more individuals, I'll generally go on to selecting it as a cluster. I'll generally select this as a cluster. So in this population, we have two different clusters. This type of selecting the individuals where there are more and there are more closer to each other is known as cluster sample. Is it clear, Ed? We'll see one example.
Mm-hmm.
Yeah. Okay. Read this just. I'll go to the washroom and come. Just I'll require 2 minutes. Huh? Just read this. Okay.
Yeah, I got it.
Okay. I'm back. Is it I hot there in US? I feel that you're
Huh?
thirsty. Is it hot? Extremely hot in US?
No, it's fine.
Oh. How is your fast going on?
It's going all right.
Yeah. Yeah. Okay. Cluster sampling is often used for practical reasons like saving time. Yes. Why saving time? Because we did not go to every individual and then see whether to select it or not, or using the D table, wasting our time. Just what we did where it was looking very crowded, we just generally selected that area of that individuals. That's main clustering. So it is time saving and money saving. So ideally, the individuals within each cluster are heterogeneous, mirroring the population. Means heterogeneous means there can be many similar properties and many what you'll say different properties in this group. Okay. So there must be many small children, many big children. That's the reason they are heterogeneous. It is heterogeneous. Heterogeneous. Okay. So heterogeneous, so mirroring the population, and cluster are similar to each other in their composition. Imagine a large high school that assigns students to home rooms alphabetically by last name. In group of 25, administrator want to survey 200 random selected students about a proposed schedule change. It would be difficult to track down an SRS of 200 students, so the administration opts for a cluster sample for home rooms. The principal who knows some statistics selects the SRS for a 8 homogeneous room and gives the survey to all 25 students in each of the selected home rooms. Be sure you understand the difference between strata and cluster. Yes, there is a difference between strata and cluster. Strata is a group based on characteristic. Okay, characteristics. And this cluster is a part, is generally a part
Hmm?
that's that is randomly selected from the population. Randomly selected from the population. Is it clear that the difference, right?
That's very clear.
Yeah. So be sure you understand the okay. We want each stratum to contain similar individuals and for large differences. Yes. Means in a strata there are similar individuals with the same characteristics. But in the clustering, for a cluster sample, we'd like each cluster to look just like population. Yes, yes. In this cluster, for suppose this is a strata. So all the people of row will be there. Row sunflowers will be there. But in this, for suppose in this cluster, if I have selected, see, for suppose this was our field and I have selected this cluster. So based on the row it will be there and also based on the column. It will does not have a similar characteristic. It will have all the heterogeneous. Therefore, this is heterogeneous. Here it is homogeneous mixture. Homogeneous means having all the same properties and heterogeneous means having different properties of each other. Sampling at a school assembly and other all. This is one example of the cluster sampling. I think we'll look into this example tomorrow. Okay. So there is then systematic random sampling also. Then we have under coverage. So these are the four big. That's the simple random sampling, stratified random sampling, cluster sampling, and systematic sampling. These were the four big random sampling methods that we had seen. Then there are sample surveys. What else can go wrong is there under coverage and over coverage. So there is also non-response. Okay, then there is response bias. Then we have finished with our first topic. That will finish it tomorrow off, inshallah. So that's the
Hmm?
things. Then in the second topic, what they have, I'll just see to it. Then they have experiments. Observational study, and then what are those things and all. We'll see it. Okay. So what I
Hmm?
think we must do that example and finish it off, the cluster sampling. Then we'll start the systematic sampling tomorrow. Okay. So what it is, the student council. Are you there, Zaid? Yeah, we are doing this
Yeah,
problem.
I'm still there.
The student council wants to conduct a survey about use of the school library during the first 5 minutes of any school assembly in the auditorium. There are 800 students present at the assembly. Here is a map of the auditorium. Note that students are seated by grade level and that seats are numbered from 1 to 800. For example, in this first row, all grade 1 students are sitting, for example. Okay. So, so now what is the question? Describe how to obtain a sample of 80 students using stratified random sampling. Explain your choice of strata and why this method might be preferred to simple random sampling. So what we can do, Zaid, it is a very simple question. We have to, I'll take this question on my board. Okay, so what we can do, we can do strata, we can perform. strata sampling, strata sampling based on the grades. Yes or no? Based on the grades which they are sitting. One can be grades, the other can be row wise, or the other can be column wise, or there can be, okay, that's simple. Okay, so grade wise we can do row wise, or we can do column wise. So explain your choice of strata and why this method might be preferred to simple random sampling. So simple random sampling, it is a very big population of 800. So depending on the SRS, simple random sampling, it will become more difficult and there will be more numbers to look at and it will require more time. But strata, what it will do,
Mm-hmm.
reduce it to 4 grades. Likewise, 9th grade, 10th grade, 11th grade, and 12th grade. There are large number of students in each grade, but strata will reduce our task for simply. So it is preferred, and the most preferred one is the cluster one. So describe how to obtain a sample of 80 students using cluster sampling. So what I'll do, generally, what we'll pick any one of the clusters from it which are having 80 students. Okay, explain your choice of cluster and why this method might be more preferred. So that's the simple reason that we have seen earlier, that in a big population, SRS and stratified random sampling is not given preference, while vice cluster is given preference because it will have it will have more differences and heterogeneous mixture of the sample. It will be exactly as the population, and we can get more accurate answers about it. So see, because students library use might be similar within grade levels. Yes, it can be similar within grade levels, but different across grade levels. Correct? Across grade levels, use the grade level seating areas as strata. Yes, for 9th grade, generate 20 different random integers for 600 to 100 and give the survey to the students. In those seats, do the same for sophomores, juniors, and seniors using their corresponding seat numbers. Stratification by grade level should result in more precise estimates of students' opinion than a simple random sample of same size. Okay, so each column of seat have the same stage to the back of the auditorium could be used as a cluster because it would be relatively easy to hand out the survey for an entire column. Label the columns, then there is the whole task. Is it clear, Zaid, how to do it? Yeah?
Yep.
Yeah.
Yeah.
So you see on the more examples from the exercise. So we have completed two things, stratified and clustering. Yeah, tomorrow, inshallah, we'll go on with systematic random stuff. Okay? Assalamu alaikum.
Mm-hmm.
You can leave, Zaid.
Okay. Walaikum salam.